number 6, the directions again were to see if it's a function or not and then say why. And if I'm looking at this, -1, it goes with 3, 0 is mapped with 2, 1 with 1, 2 with 0, and 1 with 2. I've got a red flag raised right here because an input of 1 has 2 different outputs. So my answer is going to be definitely no, it is not a function, and I'm going to say that 1 has 2 outputs and it's only allowed to have 1. Number 7, determine whether the graph represents a function and explain. So on this one, I like to do the vertical line test if we've got a picture. So if I start drawing vertical lines through each of those points, each vertical line only passes through the graph one time, and that is okay. So we are going to put yes. I could say a couple different things. I could either say it passes the vertical line test, and we definitely want to spell out vertical line test. We don't want to shorten it. Or I could say that every input, so each of those points only has one output. So every input has exactly one output. And you don't need both reasonings, just one of them. Okay, number 8 again, is this a function or not? So again, I'm going to do the vertical line test, and I'll just draw a few vertical lines. Here we go. This vertical line once, 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 and I don't see a place where I could draw a vertical line that would pass through that graph 2 times. So once again, this is a yes, and I'm just going to say it passes the vertical line test. And again, I could also say each input has exactly one output. Okay, number 9, once again, here we go with our vertical lines. Draw a few, and already I'm running into troubles because this line goes through twice, this one goes through twice, this one goes through twice. The vertical line is only allowed to pass through one time because what that's making is this input has more than one output. So we're going to say no, it does not pass, or we can say it fails the vertical line test, which again means there is an input that has more than one output. And then number 10, write a real-life problem to fit the data shown in the graph. Is the domain of the function discrete or continuous, and explain. So I'm going to do continuous. I'm going to tell whether it's discrete or continuous first. Since if I were to draw some dots on this, the dots would be connected. It's a connected graph, so we know that it's going to be a continuous. And I'll just say the graph contains all values. That's why it is discrete. I mean continuous, excuse me. It contains all values in the domain. Okay, if I had to think of a situation, let's see, something is going up. Let's see, the number, let's see, something costs $2. The number of monsters I buy, even though I definitely disagree with you drinking monsters because there's too much caffeine in them. Okay, number of monsters you buy. This would have to do with the total price of the monster. Well, actually, this would not be, this would be discrete, sorry. So we can't do that because you can only buy 1 or 2 or 3. You can't buy something in between. So let's do the number of, I can't even think of anything. The number of miles you walk and the length of time you are, we'll do that, like distance you are from your house, I guess. Okay, so I could walk 1.5 miles and then I'd be 2 miles from my house. If I walk 2.5 miles, I'd be 4 miles from my house. So I can walk I can walk a decimal or a fraction amount of miles. So that would be a situation, but do not choose my situation.